Yeah, good evening, students.
Good evening, sir.
Uh, Today we will learn how to do the analysis in SolidWorks that I will explain, and also how to generate the G codes and M codes in SolidWorks that also I will show you. Uh, and I also prepared the multiple choice questions for you. I will share you uh, by the end of the day today. Please learn all the MCQ questions, and also the tomorrow is the last date for the internship. Tomorrow is only for the session for the inquiries and doubts that you have on the SolidWorks, and I will show what are the job opportunities that are available in SolidWorks that I will show. Class ఉంది పో క్లాస్ ఉంది పోలో పో సెల్ ఛార్జింగ్ లేదు అసలు లేదు పో what are the job orders that are available on the SolidWorks that I will show, and how to get the SolidWorks certificate, like master certificate, that also I will show you. Uh, right, is my screen visible?
Yes, sir.
Okay, thank you. uh, right uh, I will draw a small part, then we will go for the analysis part. Please observe carefully, it is very very important. As we are the mechanical engineers, we need to understand how to do the analysis in CAT A and also SolidWorks. All the softwares that are which are available for the mechanical have multiple options, like generating G codes and M codes, generating animation, generating analysis. All the parts are very important. Now I will show you a simple diagram. Let us observe carefully. Uh, right, escape. Now give the dimensions. So go to the smart dimension. 1 second, someone has been admitted. Okay. Right. Now I am on the smart dimension. Enter it as 40. Right now this side it is 10.
Evening, sir.
Ah, 10 enter. Now this side also 10 enter. Make it this side also 10. Now from here to here, make it as 80. Alright, this part is 15. Right, this side 15, this side 10, and this side 15. Total it is 40. Right, all the dimensions has been constrained. Okay, if you want, you can take this also. Smart dimension. Calm go. Right, okay, no problem. Now, now here we have multiple options like future, sketch, markup, evaluate, MBD, SolidWorks, add-on simulation, MBD. Alright, SolidWorks, CAM, TBM, analysis, SolidWorks inspection. All these are there. 1 second. Now here there is no simulation of the option is there. For that, here we need to go for settings, add-ins. Just click on here. Here you will find the simulation tab. Just click on enter. I already done so that it was enabled, right? Actually it has to be enabled manually. All right, on both sides you enter, right? Click on OK. Right now here you will find the simulation tab, and also here you will find the simulation tab. Just click on that. Right, go to the new study. Right, in new study you enter new study. Right, here directly it will go for the general simulation. Here more options are there. Go for the static. Right, here plane strain. One second, it is not static one. Sketcher origin sensor, part 1, material not defined. Right, now click on static. Here you have a lot more options are there. Advanced simulation, thermal and non-linear. You go for the static. Here you enter the any name. Steady stress displacement, change factor of safety compression with linear material. Like you enter steady. Here plane stress. No, 1 second. I will take new one. It has been stuck. Oh, I had not done the extrude part. That's why it has been not came. Right. Okay. Now I got it. Right. Now all the dimensions has been completed. Go for the exit workbench. Futures. Extrude. Select the material. Sound just select here 20. Right now, okay. Now we are going to form the simulation part. Right. Go for the simulation. Go for here. New study. Right here you will get the topology, thermal, buckling, fatigue, non-linear. Now we will enter for the static mode. Right. Just click on this one. Now you will get all these parts. We need to go for the step-by-step procedure, or either also you can go for. Right. Now we are in the we are selected the static mode. Now we need to apply the material properties. For applying material properties, select the part, apply material. Right here you will get lot number of things. Now I will go for 41330 865 steel. Now here you will get all the properties values, value, units, elastic modulus, Poisson's ratio, shear modulus, mass density, tensile strength, compressive strength, yield strength, thermal expansion and specific heat. All the material properties will be applied automatically. Right here you can change the units, SI, IPS, MKS, whatever the things that are linear isotropic and linear orthotropic. Right, click on apply. The color will be changed. Just click on close. All the material properties has been applied to this object. Next step is we need to fixture. We need to apply loads and we need to fix at one end. Right, for that go for this fixed geometry. Click on fixed geometry, rolling, fixed hinge, elastic support. All these are supports. Right, click on fixed support. Now select the entity. This side we are going to fix the element. Right, here you have roller sliding. You can see the image. This is roller one. This is fixed hinge one. Right now I am selected the object. That's why it is not coming. Right now I am going to be only fix this side. Just click on the tick mark. Right, one side it is fixed and other side we need to apply the load. For applying load, this is the step. External load. Click on bottom button. Here there are lot number of forces are there. External load advisor, force, torque, pressure, gravity, centrifugal force, bearing load, remote load, distributed mass, temperature, flow effects, thermal effects and prescribed displacement. Now we are going to click on force. Right. Right. By clicking on the force, you are going to be select one end of the element, or we can elect the surface of the element. Suppose I want to apply the load on the end of this element. Just click on this line. Just rotate this side. You can see. Now the forces are applied in this direction. You can see that. Now I want to take into the outward direction. Just select here. Select direction. Right. Now click on the vertical line. Now you can see the direction is in downward direction. Suppose I want to reverse the direction. Here it is. Here you can see reverse the direction. Now I applied from the top of the surface, top of the line. Now here enter the value like 1000 newtons or 100 newtons. Right, now enter. Now all the properties has been applied to the material. First here meshing not required. It will take automatic meshing. In ANSYS we need to give the meshings. Right. Now you can observe that first we had selected new study. Second one apply material. Next we had applied one fixed mode. and we had applied the force, then all the process has been completed. Now go for the run this study. Run this study is nothing but whatever the properties, whatever the forces that we had given, either it is correct or not, we are going to checking that one. Right? Now run this study. It will take some time to study the process, solving. Right now the automatic deformation has been occurred. Here if you see that red, it is the deformation. Now here we had given the main problem and it has been deviated towards the downward direction. Right, here we can see all the we can see the animation also. Right, just by clicking on the right button you can see here animate. Click on that animate. Right, now you can see the deviation. If you want we can change the frame size also. Here we increase at 75. Now we can go for the slowly it will be coming. Right, can you observe this one? See the process where from where it was been, whenever the load has been applied it will slowly come for the deviation process. The maximum stress and maximum strain will be occurred at this place. All the colors will be applied. Now we can see the displacement also. Right, this is the displacement and we can see the strain also. Right, for strain the deformation can also be occurred. Edit definition. Right, here you go for the true scale. Click on tick mark. Now you can see where the stresses and strain, all the parameters that we can see easily. Right, we can get the results by Excel sheet, by tabular column also. That chart position, animate, select chipping meshing, probe list selected, compare results. Right, no problem. Here we will go for the animation. Here also animate. Right, see how the deviation has been occurred. Right, in this way we are going to give the simulation part in SolidWorks. This is very very important. As a mechanical engineering we need to understand how to do the simulation part also. Right, is it clear? Is it understand or not? Hello, dear students. Can anyone respond? Abdul Matlab,
Yes, sir.
Jafar, is it understand?
Yes, sir.
Okay. Uh,
Yes, sir. Hello. Yes, sir.
okay. You go on practicing like this. We can change the design. We can give for the circular models. We can have different types of material properties. By changing the material properties also we can do that one. Just click on apply materials. See lot of material properties are there. Only it is for steel, iron, aluminium, copper alloy, titanium, zinc alloy, other alloy, plastic, other metals, other non-metals, generic glass fiber, carbon fiber, silicon, rubber, wood, sustainable extra, custom materials. All these are all the different types of materials. Here there are also some more materials: copper alloy, steel alloy, nitriding alloy, stainless steel. All these also. These are all the different types of material properties. Tablets and curves, appearance, crosshatch, custom application data. All this we can be having in the material properties. Like results advisor, we can give the results. We can also, one second, we can also view mm, configure. Export in DWG is also there. Face properties. We can see here meshing also. I had seen it. Result options. only. Chart options. You can see all the differentiation also. Okay, I will show one more video today. It is how to generate the G codes and Gen codes by using the what we called as cutter location data, and while doing the while generating the G codes and M codes, we need to do the right, what we called it as foundry process. Cope and drag has to be prepared. Cope is the part that which the bottom of the foundry will be there, and the top of the part it will be called as drag. First we create the empty section, then after that we will fill the section, then further G codes and M codes are generated. I will show you that video. We will practice this tomorrow. I will show you today. Otherwise we will show this video. After that we will go.
And we're back.
Here it is there. No.
Dimension and make the single strip, steel strip.
This was done
That's
in
it. Now let's see how
You can try
to
this for sheet metal also.
run set up a simulation. So just go to add-ins. Now choose here SolidWorks simulation. Check both the boxes. Select OK. Now see in window menus you can see simulation arrived, and even you can see here simulation window arrives. Now I'll choose perspective so it looks better. Select here new study. Now in we will choose here statics. In statistics we can calculate the displacement, reaction forces, stresses, strains and factor of safety for distribution. So these things we can calculate in statistic way. So select OK. Now this is the window of SolidWorks simulation. Now here we need to fill some necessary things. First, material. Select the part, apply material. So I'll choose the same material what we applied before, steel 4130 steel annealed. Apply, close. Now the material is applied. The next thing is fixture. We have to fix anyway because this is a single part, not assembly. So we have to fix any one wall. So let's apply here fixed geometry. So I'll apply fixed geometry and I'll check this face. Now see, it's fixed. Okay. Now one side is fixed. Now the second thing is external load. So let's collect forces. We want to apply forces on this any one corner, and we will see the displacement and stress analysis. So I'll choose this one corner. I'll not apply on the surface. I'll apply on this corner. Now you can see the direction of displacement. It's not downward direction. So there is one option in your left hand side, just below the normal. Choose here selection direction. Once you select that, then you can choose here downward direction. Now you can see the arrow goes down. That means your forces applying from top to bottom. Now here at the bottom, you need SI standard and forces. I'll apply 1500 Newton. Let's see what will happen. Select yes. Now here we fixed and apply the forces. Now the third thing and last thing is mesh. Mesh actually it is also a very useful thing. If you will right click create mesh, if you will make the fine mesh, you will get the perfect result. If you will make the less and meshes are become big, then your result will be or output will be not accurate. So I'll try to, either you can just drop this bar, or if you will come down mesh parameter, you can adjust from here anything like this is, let's say 3. Now see the bar is moved. You will get the fine result, but the calculation will take too much time, and even your graphics will take too much time. So if you have less graphics, less CPU, it may difficult for your PC. Maybe it will hang your PC. So be careful for this one. Select OK. Now it is calculating. Now you can see the mesh, all equal meshes, all around the equal meshes. Now let's run this study. Yes, now it will going to solve our problem, and we will see the displacement and everything. That's why see I choose the mesh is smaller, then the result will take too much time. So always keep in midway, but definitely the fine mesh will gives you fine result, or a result will be closer to the accuracy. Still it's working because we choose fine mesh. Okay, that's solved. Now you can see a big displacement. See, we applied the force and how our strip is bent, and this red color shows the maximum number of stress. Here chances of breakdown. In your right hand view, you can see this column, stress column. So this is shown in Newton per square meter. Actually our geometry in mm, so we need Newton per millimeter square. So right click, edit definition, and choose here unit. We need mm square. Select OK. Now here you can see it. Now here you can see a red arrow. This red arrow means it indicates material begin to deform from here to plastic shape. So right click on stress, click animate. Now see how it is rotating, how we applied the force and is going to move. If you will reduce, then it will reduce. Stop. 50. Play. It will calculate, and it may takes time, but if you will increase the frame rate, it will gives you accurate result, and your geometry and your movement will be very, you can say, fine, and I hope you understand. See, it's moving very smoothly, and you can see. Select OK. Now see, this red color shows the maximum stress, means the deformation will happen here. Now double click on displacement. Now you can see the maximum displacement is 2.463. Double click on strain, and here also you can see the maximum strain 4.9 mm on 1500 Newton force. Now here let's examine, just double click on stress, and you can see this red area, it shows the more stress on this area. So let's examine, just right click on stress, select probe, and select anywhere in this left click. You can see it shows the location and value. Right click, cancel this.
जिंदगी में सेव करना जरूरी है, मगर जब बात पैसों की हो, सिर्फ सेविंग से काम नहीं चलेगा। इक्विटी म्यूचुअल फंड्स में इन्वेस्ट कीजिए और अपने सेविंग्स को
Now here we will reduce this circles are check to right click.
We will see one more model.
Cam tutorial today we okay, choose here fillet, keep 7 mm and select the all outer edges. Okay, now select this face, sketch, and here draw one straight slot. Choose the midpoint, any dimension. Again choose, select midpoint, through all. Okay, select add-ins, and here you will find out SolidWorks and select here simulation. That's it here. So now here drop down this menu and find new study, select statics, and here you can select the we will do. Now we entered in, you can see simulation window. Select first part 5, apply, close. Now see, this is the plane. So I select this back side face will be fixed. Select OK. Now this back side will be fixed. So here we will apply the load and we will see, we will study what exactly required and how to manipulate. Select here now external load. Let's apply external load. Select right click, and here see multiple number of loads. I prefer force. Now I apply force in this surface, and Newton, let's say 300 Newton force. Okay, now let's make the mesh. Click mesh, and here select mesh, and mesh it is by default. You can select by yourself also. Select 3. Now see, it's calculating. Now you can see the mesh. Go to load and right click. Now see, we applied the load is extra. You can see here. Yes, right, and select here. Just click this save now. Chart options 10. Previous step, strain also. Do and more projects in SolidWorks. Don't forget to share and like our videos. Thanks for
Here
watching.
You can find all the model details. Right now I am going, it is very important, how to generate the G codes and M codes. This is the steps that we required. Model part, SolidCam add-in, define machine, coordinate system, stock manager, mill setup, extract machinable feature, generate operation plan, generate tool path, simulate tool path, save CL file, post processor. These are all the 12 steps that we need to follow for doing the for generating the G codes and M codes.
Here we will learn basics and we will do one simple exercise. First we will create a plane or a model. I'll choose so start. Now X front side and dimension 40 millimeters. Say okay. Again I'll select top face. Now let me create few cutting paths. Go back and convert into arc. Connect line. Okay. Now activate circle tool. Let me draw here 2 circles. Let's define this all. 105, 70. Let's define this also. 35, 20, and one more distance from top edge. 35.
అన్నా వచ్చిండేమో చూస్తూ ఉండనా సిస్టమ్ ముందర క్లాస్ చెప్తాను ఓకే ఇంటర్న్షిప్ అన్న నేను చెప్తా ఊరుకుంట్రా రాలేదన్నా ఇంకా రాలేదన్నా ఏమి అనౌన్స్మెంట్ రాలే 8 తర్వాత ఉన్నాడు 8 అయింది చూద్దాం ఇంకా పెట్టలే మరి వస్తే చెప్తాలే
Okay, let's do one more relation. Hold shift key, select these 2 circles and make constraint equal. One more constraint, let's select the center point of both the circle, hold shift key. Now here we want to cut this all. Before going to choose anything, just open selected contour and select. If you move cursor, the things will become orange color. I'm going to choose this one. Depth 20 millimeter. Keep end condition blind. Say yes. Again select the sketch, extruded cut. Again go to selected contour and this time I'm going to select these 2 circle holes and depth make, let's say 10 millimeter. It will be more visible, that's why I keep 10 millimeter. Say okay. Again I'm going to select sketch to extruded cut and in selected contour I'm going to choose this time this hole and make end condition through all. The last operation, select, extruded cut, selected contour. This time I am going to choose this one, 20 millimeter. Say okay. Now that's perfect. Now if I make like this, let me save this one.
From here,
Cam exercise.
This is the general up to this was the designing
Now
the part.
right click. The cam SolidWorks cam available or not. If not, then either go to tools or simply open from here, add ins, and here you will find option SolidWorks cam 201. Don't check this one, otherwise your cam tab will always be open. So I'm going to choose this one. Okay, now let's see, the tab will come here. Like the tab is come here. If you open your design manager tree, you will find here 3 options. Now first one is feature tree, the second one, the middle one is operation tree, and the last, if we click operation tree, see these operations we have to perform. The last one is tool library. What kind of cutting tool available in your library? These are the things which is you can change it according to your need. So keep operation cam, operation tree, and first thing you have to define machine. See here, right click on the machine and you will see this tab. Now first operation, mill metric. machine I'm going to select this machine. Now here also see tool crib. In tool crib there are multiple number of tools which is available in your station. Now if you come down, available tool crib, there are 3. In each station there is 20 number of tools. Even though parallelly you can add tools, remove tool, edit tools or update tool list. Make sure your cutting tool always be smaller than the hole size. But this all system going to be automatically. Now post processor, here you have to define your machine. Your SolidWorks CAM don't know the machine, so you must define. By default it's already selected mill tutorial Fanuc type. Then there are few more settings we will see in coming lectures. Now here keep machine medium duty, let's say OK. Now the next option is coordinate system. Now always make sure Z axis on top side because the tool coming from top side. If not, then you have to manage through this axis. But in this case we don't need, so simply say yes. Now next is stock manager. Stock manager is nothing but the raw material which is going to use to cut these things. Now here the code and material, let's say aluminium alloy we want to cut. Now type, stock type, it is a bounding box type. If you want to add any material, let's say see 20 millimeter, you can add it 10 millimeter or let's say 2 millimeter, and this all let's keep 0, and we will see at the end it will show you the surplus material. Let's keep as it is. Now stock also defined. Let's choose setup, mill setup. Now mill setup, the cutting going to start from the plane, so I'm going to select this top plane, top face. See, you will see the arrow goes down. It means tool coming from top, and this is the 0 surface from where it starts cutting machine. Say OK. Now these all are set. Now there is next option, extract machinable feature. It will tell you what kind of operation you need to cut this tool. So simply click and it is going to calculate, and see these are the operations you need to perform to make this simple part. Now after that there is one things called generate operation. So click, see you must select, then select. So these are the plan, roughing plan, cutting plan, roughing, cutting. So first it will roughly cut, then it will finish. See, rough finish. So these are the things you can going to cut. So again select mill operation, plan already generated. Now let's generate tool path. Oh look, it's also generated tool path. If you click any one operation, see it will highlight you what operation is going to perform. Okay, anyway this is the plan. Tool path is already generated. This is the actually process going to cut. The next option, simulate. So click, make sure you selected mill part setup, simulate tool path. Okay, this is your tool, a stock manager, the basic raw material. Now here I am going to select, okay, change this one. Speed you can reduce. Now here I want to see shaded display, that's fine. Here translude. Now tool shaded with edge, it will show you all. Okay. Now okay, let's play, run, look how it is going to cut. First this is going to cut your oblong hole. We make the speed slower so that it will be more visible. First rubbing, then cutting. It will cut in two process actually, not in one process. Now the next operation, it's going to take Let's increase little more faster. Okay, let's do this. Now you will see 2 mm material we added at the top. You will see those added material. Now see, these holes are going to cut. Now this center hole. If you see this one X, Y, Z, it will show you the traveling path of tool. Okay, now see this blue color, it is extra material we added at stock, so it will show you in blue color, and this is the our cutting material. If you change display difference, see. Okay, now the next thing is save CL file. CL file, it is nothing but the cutter location file where cutter moves around. So let's say cam file. Look, these are the cutting location. It will show you where tools moves. Now the next most important thing, generate G code for machine, which is the most important thing, and that is called post process. Click on post process. Now type file type, keep tab file, give the name, save, and here click play. Now it will generate all the G codes. Say okay, come down, play cam exercise. Now look, now see, these are a G code file. Simply copy in your pen drive and transfer to the machine. Machine will read and do the needful job. So I hope you like it and you understood how SolidWorks works. These are the few steps which is necessary to create a G code to cut a parts in machine. I hope you like it. Don't forget to share and like our video, and please subscribe our channel for more video and more projects in SolidWorks. Thanks for watching.
Looking to take the
Right, is it clear? Is it understand? In this way we are going to have the generate M codes and G codes. We can do the simulation for heat flow and thermal analysis also, but the processor of the system should be high, and it has to be the graphic card, so that it will complete the process as early as possible.